Hopefully you all are well and try to achieve your life goals. Okay, so in this video we try to understand the evolution of number system. We try to we try to understand how the number system forms and why we need of the layers of that number system, like natural layer, natural numbers, whole numbers, integers, rational numbers, why we need, and how they evolve from here to here to here. Okay, so suppose in our past, okay, when there is in our history, there is a nothing to count anything. So for that we need something so that we can count. Okay, previously there is nothing to count. Okay, we assume that, but then somebody think about it and try to um, create something so that we can count anything. So for that, first they discovered objects. So everything is object, and for counting them, they create a natural number. So everything is object. Like this is an object. Okay, suppose this is an object. This is one more object, and this is another object, and then this is the another type of object. This is the another type of object. This is something else. These all are objects. For counting them, we discovered, or we created the natural numbers because we can count them as a 1, 2, 3, 4, 5, 6. Okay, so don't try to make it so much complicated. Just understand, if there is an object, then to count that objects, they created natural numbers. If suppose you have nothing, okay, first you have many objects, okay, but if suppose you have no object, how can you count them? How can you represent object which you not have? Like if you have three trees, you can count them as three. If you have five trees, you can count them as five. But if you not have any tree, then how can you count them? Okay, how can you count them? So for this type of problem, we created the whole numbers in which we include zero. Okay, it means zero is means nothing. Like you not have anything, so you can indicate it with the help of zero. So suppose if you not have any object, like you don't have a single house, you can say that I have a zero house. I have a zero number of house. If you have no money, you can say I have a zero number of money. Just for example, we can say that. Okay, so for that we created the whole number. So from this onward, we can say that previously there are people try to calculate the objects only. They discover objects that they can see that these are the objects, and for counting the object they created a natural number. So what is natural number? Natural number. Oh, I'm sorry for this. Okay. What? Oh, natural number. Yeah. So for natural number, how much natural number? There is one, two, three. Sorry, 2, 3, 4, 5, 6, 7, 8, 8, 9, and okay. What is whole number now? A whole num number is equal to nothing but 0 plus natural natural number. Okay, so this is how natural numbers comes to count objects. But after that, they think about, if they not have anything, no object is there, how can you represent them? With the help of zero. So combined, we can say them as whole number. Then there is come integer. Now it is a little bit hard to explain. Suppose you can now calculate the objects, you can represent them, but how can you represent your need? How can you represent your need? To represent your need, they created the negative numbers. For more explanation, suppose today is your birthday and you want to distribute chocolate in your class. Suppose you have 10 chocolate, okay, but in your class there is 15 is to 10. Then what you do? In this case, you have a chocolate 10, but there is a total 15 students. When you subtract it, you have, oh, sorry, you have a 10 chocolate. In your class there is a 15 student, so you are in a 5 negative. Means you need a 5 more chocolate, and when you get 5 more chocolates, then all things is okay, no problem. So in this example, you can understand this thing. Let me see one more example. Suppose suppose what, okay, suppose you are doing some business, you are running any business, okay. In business two things are there: loss and profit. You can indicate profit by any of the number, like today you get 40% profit, next day you get 30% profit, no problem, you can indicate this thing. But how can you indicate the loss? You can say that today I got loss of 40%, okay. You can say that today I got loss of 20%. But when you try to make the record of it, when you try to make the record of it at that time, how can you represent loss as right now? When you make a sheet of your expense or your profit loss, you can't write there that you get lost, you have to calculate for any loss. You can indicate with the help of negative, okay. That you need, you lost 40%, you need the 40% money, you want to gain the 40% money too, so that you the overall profit you have would be neutralized. For that you need 40% more. So now if you to add them with, so that now you can say that in whole day, you get 10% profit. But how? With the representing of this is the loss and this is the profit. When you add them you get 10% or that all, or 10% overall profit. So here you can get something about the use of negative numbers, okay. Like here the overall profit is here also 10%. So you can say that the loss is in negative and the profit is always in positive too. So as from this example we can say that to represent our need, to represent our losses, we use negative numbers. So after that the integers are formed. So now what is the integers? Natural number, the whole numbers plus the negative numbers, okay. So here you can say that the integers are nothing but the whole number plus negative number. It is an integer, okay. Now you, oh, now you efficiently define the whole number, integer and natural number, no problem. You can count objects, you can represent your need with the help of negative numbers, you can represent your loss. But suppose this is the wooden block, okay. Suppose this is the wooden block, okay. You have one more wooden block, you have one more wooden, no problem, okay. You can count them as a 1 and 2, but how can you measure them? That how much long this would, how much long this would, how can you calculate them? How? Okay, and now you can calculate them with the help of meter, but at that time there's nothing to calculate them, okay. So for that they created unit, measurement units, by the help of which they can calculate, they can measure the length of anything, okay. So like we can say that suppose this much is the one unit, okay. One unit, this is the second unit, this and this and this, okay. So 1 2 3 4 or 5, you can see that, okay. Rest of it I will erase it. Mm, sorry, yeah. So what they decide that this is their 1 meter, okay, no problem. This is their 1 meter, okay. This length is a 1 meter, so they again try to put this in this. So this is 2 meters, now this is 3 meters, now this is 4 meters, this is 5 meters, okay. So they just made this length be considered as a 1 meter, and with the help of this length now we can calculate any of the thing, okay, any of the thing. So this is what 1 meter, okay. This is 1 meter, and the total length of this block is 5 meters. Now they again try to measure the second block. Okay, so they start with the same thing that this is the 1 meter. Okay, this is the 2 meter, this is the 3 meter, this is the 4 meter, this is the 5 meter, and suppose this is the 6 meter. Then what about this part? This part, what? How they measure this part? Because they consider this length as a 1 meter. So this length again is a 1 meter, this length again is a 1 meter, this length again is a 1 meter. So they add this length, this length, this length, this length, and this length, and this length. So they can say that this is 6. How they calculate this? So for this problem, they came with the solution as a rational number. That they disintegrate the number in a points. So with the help of the rational number, now they can say that, okay, now they can say that this is a 6. Suppose this part is a point 2 part, 0 point. So you can say that this is a 6 complete part. From here to here, this is a 6 complete, and above it is a point 2 part. Okay, so they rational number. Now, what is the rational number? The any number which can be represented in a p by q form. The any number which can be represented in p by q form is a rational number. So we can represent this number as a rational number. How? This is a nothing but the 62 by 10. So here you can say that this is the p part and this is the q part. Or you can say that this is a 31 by 5. Okay, this is the thing. This is this. Yeah. So any number, now this is a decimal number. Okay. So any number which can be represented as a p by q form is a rational number. Or you can say that the any number which we can represent in a both way, in a decimal form also or in a p by q form also. Or we can create from decimal to rational form, and then from rational to decimal form is a rational number. Any number which can be converted from decimal to a fraction and from fraction to a decimal is a rational number. Okay, any number which we can convert from decimal to a fraction and from fraction to a decimal is a rational number. Okay, when we can't measure anything completely, so we have to do what? We have to disintegrate that thing. Okay, it means this is the 0.2 part of a complete 1 meter part. Okay, this is the complete 1 meter, and from this 1 meter, this is only a 0.2 part of it. So we add it in the complete part, like in the 6 is the complete part, and this is the remaining part which we can't measure with the help of full unit. So for these parts, for to count the remaining entities, we created the rational numbers. Now there is a rational numbers also. So as I mentioned, as I try to explain that the any number which we can represent in a decimal, and then we can convert it in a fraction, and similar the number which we can represent in a fraction and then we can convert it to the decimal is a rational number. But if we can't do that, then that number is an irrational number. Like you can know about the value of pi 2 by 7. Okay. Here you can see that we can represent this as a p by q form. But when you divide this number 22 by 7, the number comes is 1 by 4, and that means it is not stopping. It is not giving any definite value. It means you can represent it as in for a fraction form. But when you convert from fraction to decimal, you can't get an exact value. Okay, at that time you can say that this is an irrational number, because if you get this value you can't convert it back to this value, and if you get this value you can't get a definite number in decimal form. So this is an irrational number. Suppose you have another number. No problem, you want a root of 2. Okay, so the root of 2, what it is, here you can see that this is the root. In my keyboard there is nothing to represent the root, so I written as this. Suppose this. Okay, this 2. So what is the value of it? It is something like 1 point or I don't know what, so I calculate it. Yeah, it is a 1.414, and then again it continue. In this you can also say that you can't represent this as a decimal and from decimal to the fraction, because it is not stopping, it is continuing, increasing. So you can say them as a non-repeating decimal numbers also. Okay, and you can say them as an irrational number, because we can't convert it in back to the rational form, or you can't represent this as an irrational form. So these are the irrational numbers. From this whole explanation you again got one confusion, one doubt that this this you can represent as p by q. This is the single number. How can you say that this is also a rational number? We can see them as a rational number because if any number, any complete number, have nothing as a denominator, then simply we can write 1 as a denominator for it. Okay, 5 by 1. Because when you anything divide by 1, it just become the same number again and again and again. Okay, so now from this example, you can understand about the irrational number and rational number. Okay, now there is a two type of numbers. Okay, just I try to explain it. Okay, now in rational number or in irrational, or you can say that in real numbers there is a real number. Okay, there is a thing which is a decimal number. Okay, decimal. But in decimal number there again comes two type of numbers: non-repeating decimal number and repeating decimal number. Okay, so as we mm, as we try to understand this thing, what is repeating decimal number and what is non-repeating decimal number? Okay, the repeating decimal number is what? Suppose you divide 10 by 3. Okay, what is this? Yeah, what is this? Sorry. Suppose you divide 10 by 3. You got that 3.3333 and it is continue. So this is the repeating decimal number. For them, we represent as a 3.3 and it is on it. There is a bar. So this bar represent that this number is repeating. Okay, so these are the repeating decimal number. These are the non-repeating decimal number. So I just copy them, Control C and then Control V. Okay, these are the non-repeating decimal. Okay, so it always say them as a real numbers. Okay, and these are the decimal numbers. And decimal numbers are non-repeating and repeating numbers. Okay, one more thing. Real numbers are those numbers which have their existence, which are possible. But in our universe, there are many things which are imaginary. We just imagine that they are exist. They can be exist or they are exist. But there is no real meaning, or we can't represent them, or we can't define them completely. For that, things we say as an imager. So for that, there is an imaginary number also. These are real numbers. There are some imaginary numbers also. Okay, so imaginary numbers. Imaginary numbers. Okay, imaginary numbers. Okay. What are the imaginary numbers? These are the imaginary numbers. Suppose you have a root minus 1. In root, if anything is minus, then you can't get answer of it. Okay, you can't define it. So for that, we say that these are the imaginary numbers. We represent it with I. If there is any root, suppose you have 3 I. What it means? It means that there is a number which is like a number, okay, which is a 3 multiplication to this. What? Multiplication to this. What? This. Okay. Oh, sorry. Multiplication to Control plus C, Control plus V. This. Oh, what happens? You can see that this is the it is about nothing, just a equal to 3I. It is 3I. This is the meaning. These are imaginary numbers. We can't. We are unable to define them, so we say that these are imaginary numbers. Okay, they have exist in math, but then also in real life, no use of it. So we consider them as imaginary numbers. Okay, thank you. I hope you get everything. If you not understand, then please give review and ask me if any doubt. Thank you.